Hello everyone. In this tutorial, we will understand another circuit of rectification circuits for producing high voltage DC. This circuit is full wave rectifier but with bridge circuit. So, this circuit for producing high voltage DC. In this circuit, 4 diodes are used for fully rectification. So, this is the equivalent circuit of our full wave rectifier bridge circuit. First of all, we have high voltage transformer here to produce high voltage AC. So V input here is the input voltage to our rectification circuit. V input here is also the voltage of the secondary of our high voltage transformer. As we observe, in this circuit we use 4 diodes, D1, D2, D3, D4 for fully rectification. Also we have a capacitor here for reducing the ripples. Also we have RL, which is our load. Also we have V output, which is our output voltage, and we can predict that V output here will be high voltage DC. So this is the input voltage and this is the output voltage of our circuit. Now it's time to see and understand the operation of this circuit. First of all, in the positive half cycle, the diodes D1 and D3 will acts as short circuit, as the voltage across D1 and D3 during the positive half cycle will be positive. So D1 and D2 now are closed switch. So the capacitor C1 is charged. And the direction of charging of the capacitor and the direction of flowing the current will be like that. The green line represents the direction of the power in this circuit. First, the power comes from the power source, then it passes through D1 and also the capacitor is charged, then the power passes through D3 and come back to the power source. After that, when the capacitor reaches the maximum voltage V maximum, D1 and D3 are off now. So D1 and D3 can be considered as open switch or open circuit, and the capacitor discharges through the load resistance like that. So the capacitor will discharge through the resistance like that. In the negative half cycle, at this moment, the diode D2 and D4 here will conduct, so they act as a short circuit, so the capacitor C1 is charged and the direction of charging the capacitor is that direction. During the negative half cycle, this is the direction of charging the capacitor. As we see, the power passes through diode D2 and diode D4 and the capacitor is charged in that direction. Also, when the capacitor reaches the maximum voltage V maximum, so diode D2 and D4 will be off, so they act as open circuit and the capacitor discharges through the load resistance, and this will be the output waveform of our circuit. The blue line will represent output voltage. As we see, it's a unidirectional or DC voltage but with some ripples, and the difference between the maximum and the minimum voltage is 2 delta V, and delta V of course is the ripple voltage, and we see the solid sinusoidal wave is the input voltage. From this waveform we can deduce that during the positive half cycle, the capacitor charges when D1 and D3 on. After that, when D1 and D3 off, the capacitor discharges, so the voltage decreases. After that, D2 and D4 will charge like that. D1 and D4 are on, short circuit, so the capacitor charges, so the voltage increases. After that, D1 and D4 off, so the capacitor discharges like that. So this is a simple operation of our circuit for producing high voltage DC. Now let's see the features of our circuit. In this circuit, the ripple voltage is halved compared to half wave rectifier, and this is a big advantage of the full wave rectifier circuits. as in full wave rectifier circuits, the ripple voltage is reduced compared to half wave rectifier circuit. So this is a big advantage, and the ripple voltage can be calculated from this formula. Delta V equals V maximum over 4FRL times C. Also, the maximum output DC voltage produced in this rectifier circuit is approximately equal to the peak value of AC voltage of high voltage transformer secondary. This is because we use high voltage transformer and not center tapped high voltage transformer. So the maximum voltage here equals to the maximum voltage of secondary of our transformer, as no center tapped high voltage transformer is used. So the maximum output DC voltage produced equals to the peak value of the voltage of our secondary of high voltage transformer. So we can calculate our DC output voltage from this formula. V output DC equals V maximum times 1 negative 1 over 4 FRLC, where F is a supply frequency, which is 50 or 60 Hertz, and RL is our load resistance, and C is a value of smoothing capacitor. It's very important to understand that the values of the capacitance and V maximum, which is the maximum voltage of secondary of the transformer, are adjusted and designed to give a specific value for the ripple voltage and the DC output voltage during the design of the circuit. So this is a complete understanding of our full wave rectifier bridge circuit. Thank you and see you in the next lectures.